But now let me show you what this looks like geometrically. So geometrically, we interpret this as the area under a curve. Here's the a piece of the curve y equals 1 over 1 plus x, and it's going up to 4 and starting at 0 here. And the first estimate that we made, that is the upper bound, was by trapping this in this big rectangle here. Right? We compared it to the constant function, which was 1 all the way across. This is y equals 1. And then we also trapped it from underneath by the function which was at the bottom. And this was y equals 1/5. And so what this really is these things are the simplest possible Riemann sum, sort of a silly Riemann sum. This is a Riemann sum with one rectangle. This is the simplest possible one. And so this is a very, very crude estimate. You can see it misses by a mile. The larger and the smaller values are off by a factor of 5. But this one is this one is the lower Riemann sum. And that one is less than our actual integral, which is less than the upper Riemann sum. Okay? And you should by now have looked at those upper and lower sums on your homework. So it's just the rectangles underneath and the rectangles on top. All right, so at this point, we can literally abandon the mean value theorem because we have a much better way of getting at things. If we chop things up into more rectangles, we'll get much better numerical approximations. And if we use simple-minded expressions with integrals, we'll be able to figure out any bound we could get using the mean value theorem. So that's not the relevance of the mean value theorem. I'll explain to you why we talked about it even in a few minutes.